My channel. In this video, I'm going to cover C++ initialization. There are multiple type of initialization. So the idea is to give like an overview of all the initialization at one place, so that we can understand it better and make sense on topics that we'll cover later in this channel. Um, as a reference for this video, and in general for my C++, I use C++ Primer, a 5th edition book, which is pretty good. Um, and most of this is I've learned through that um, or through internet searches. Um, so there are mainly 5 type of initialization. There are few variants of this. This is not a full list. There are few more, but these are like the main initialization. The first one is default. Default initialization is when you initialize an object without an initializer. So you specify nothing, and that's the default state you get. The second one is direct. Direct is when you initialize an object with an explicit like explicit set of arguments for the constructor, and then compiler picks the right constructor for you. So it's very direct form. You specify exactly which constructor you want to initialize your object with. The third one is copy initialization, which as name indicates is just like you initialize an object from a copy of that object. The fourth one is list, which is new in C++11. The idea there is like you initialize an object from a from a brace list of initializers. Like you have a container, and you can initialize the elements in that are specified in a brace list. That's the main idea there. And the final one is value initialization. The idea there is like that you initialize an object with an empty initializer, and now it's up to that class to basically initialize it whichever way it desires. And I want to mention one more thing. There are like built-in types, and then there are like user-defined types like classes and things like that. And things changes between those two, and I'll try to go over all of these and try to show the differences. I'll also use either some user-defined class or like a container class to just show the difference or show where things get little bit different. So let's go to the default initialization. As I said before, there is like no initializer that's specified, and it's applicable both on the built-in type and on a user-defined class. On a built-in type, you need to be very careful, because on built-in type, it's like basically does nothing. You will get whatever is it's basically undefined state for a built-in type. For example, if you define an int, if you define a variable of type int, you won't know what value goes in there. But for a user defined class, it depends on what user has defined in terms of its default constructor. And if it has implemented a default constructor, and if that constructor is doing something, then you will get a proper initialized state. So it depends on the default constructor. So for example, in the point class that I defined a default constructor which basically initializes the x and y to 0. In this case, like default constructor will create a class with a 0.00 in xy coordinate. is direct initialization. In the direct initialization, and it's also applicable both on built-in type and user-defined, we can specify directly what constructor we want to choose. For built-in type, and the syntax is like, in the parentheses you specify the set of arguments that you want to pass to your constructor. And so here you specify the value, and then that's the value gets initialized with an and as you can see, it requires like that constructor. For a user defined class, it requires that specific constructor to be there. For example, for point class, I define this constructor which explicitly take x and y, and initializes class member variable based on that. So that's exactly the direct initialization does. It directly calls a specific constructor based on the arguments. The third one is copy initialization, which is easiest of all the forms of initialization, just not as performant. The idea there is like you initialize an object from a copy of another object. So you can see that I create a class P1, and then I initializes a class P2 as a copy of P1. Um, so as you imagine, you will get like x and y for P2 as 200, 200. The next one is list initialization. This is new. As I explained above, the idea there is to initialize from a braced list. So you can, for example, define a built-in type. You can initialize a built-in type with the initializer, and then in that case, you will get a value initialization. And I'll explain a little bit later what that means. Uh, so bear with me for a second on this one. For the class, you can specify like you can specify what elements. For a container type, for example, you can specify the list of the elements, and it will populate the container with that element. It will initialize that many elements in the container with the specific values, and it's especially very useful for like for vector array, um, in case you want to populate it with the specific values, but containers in general, it's very helpful. The 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 final one is value initialization, um, which is which was little bit tricky for me, but the idea there is like you do not specify like a specific value there, and when you use it with the brace initialization, all the elements that are there in like specifically with array, all the elements that are in there get value initialized. So if you have an integer, then you get all the elements initialized as 0. If you have, on the other hand, like say if you have an array of point object, then you will have like the point default initialized. So here you will have your points your points default initialized to 0, 0. So that's the main idea there, and you can do it with like with vector too. Like for example, vector takes a constructor where you can pass the number of elements, but you choose not to pass a specific value what you initialize. Like you can also choose it to initialize it to a specific value, like let's say 100, but you can also choose to omit this. In that case, like all the elements in the vector are value initialized, so they'll get initialized to 0 in this particular case. So these are the different form of initialization, and we can also look at them together, like especially with like containers, it gets very easy to see them together. Like if you just define an object of a specific container that's default, which is like an empty vector. Um, if you define a vector with with a specific element count and value omitted, then like it will basically do first do it will do a direct initialization of that vector to create a vector of 10 elements, and then value initialize all those elements in the vector. The third one, copy, you can just create from the v3 from v2, which is just like a copy. But this is also this is copy initial. This is still calling copy constructor, but this is like a direct initialization. The fourth one is copy initialization, because there you are using the equal sign. There you are specifying very clearly that you want like v4 as a copy of v3, and so this is like a slightly different from the direct initialization. And the fifth one is the list initialization, which is where you specify a list of elements, and that's what the vector gets populated to. So that is basically um, all the all the initialization that you need to know. It comes very handy if you need to um, to define to initialize something for like some problems or something. There is also a way that this is used with the dynamic memory. I'll cover that later because that requires touching some other things. This is also very closely related to construction of an object, which I'll also cover in a follow-up video. So that's all. Subscribe to my channel if you find this interesting. I'll be covering a lot more basic things like these, um, uh, uh, and um, and we can and put your thoughts in the comments if anything in particular you would like me to cover, or if you have any suggestions. Thank you. Bye.